For this video, we'll be talking about basic set operations such as union, intersection, difference, complement, and the De Morgan's law, since it will be useful in solving set operations. So first is the union operation. The union operation is represented by this symbol, which looks like U for union, and we put these sets beside it. So in this case, what we basically do is we add the elements of the set, say, so let's put it here. So say we have a Venn diagram out here, and we have two sets, say A and B. So the representation for this one is, since we're adding the elements from A and B, so we simply shade the elements of A as well as the elements of B. So this is its representation. Next is the intersection. For the intersection, we denote this with this symbol. Looks like a reverse U, and we put these sets beside it. So what we do here is we take the common elements between the two sets. So to visually represent it, say we have two Venn diagrams out here, say A and B again. So let's say if this color blue, represents the elements in A, and this color green represents the elements in B. As you can see, the only portion the only portion in this diagram wherein both colors are present is this one in the middle. So remove this one and this one, and we arrive at this is the representation of the intersection. Next is set difference. We denote this by the minus sign, and similar to the first two, put the sets beside, so A minus B. So as a representation, again, we have sets A and set B. So what we do here is we take the elements in A, so say again, this one, this part represent the elements in A. And what we do next is we remove the elements that is present in B. So that will be this part out here. So this one is the representation of A minus B. Now we go on to the complement of set. We denote this by using letter C above, or you can also represent this using this symbol out here. It's like an apostrophe. So to visualize it, say this is, we set this whole set as U, or universal set, which means it's the set that contains all possible elements. So say if this is set A complement represents to all elements in the universal set that is not A. Similarly, it means, as I say, all elements in the universal set minus A, not in A. So to represent it in a Venn diagram, or in a diagram, it contains this portion around. As you can see, it does not contain the inside because that is A. So lastly, we discuss De Morgan's laws. The De Morgan's law is like a combination of union, intersection, and complement. So it's represented by A union B and A intersection B. Then we have the complement over here. So when we think of this, what is the possible outcome of this one? So the outcome for this one is A intersection B, wherein A and B are the complements. And the same goes for the next one. A union B complements. So as you can see, what happens here is that it's like we distribute the complement between on the two sets, and this sign is reversed. So we show the diagram for this one, but only for the first one, since the idea for the second one is similar for the first one. And I will leave that as an exercise. So say we have this first set. This is the A union B complement. And this is the A complement intersection B complement. So for this example, so this one to solve. So first we have A union B. So A union B represents this one. But since we're taking the complement, we remove the A union B part and take the outer or universal set minus A union B, which is this one. Next is this one. So we have A complement intersection B complement. So let's first represent A complement with the blue marker. So the A complement part represents the part where A is not included. So it's this part. While B complement part represents the part where B is not included. So let's take the green marker and shade that part where B is not included. Next we take their intersection. So their intersection represents, in the diagram, the part where blue and green are present. So as you can see, this part of the diagram is part where green is the only one present. So remove that one. There's no present here, so we don't include that. And then this part is only for the blue or the A complement. So you can see the rest of the diagram is their intersection because it contains both colors. So clearly, these two sets are equal. So that's all for today, and we'll discuss more examples in the next video.